First fruit. Oh, darn it. All right. So we have LS, RS, and this is H. So you have secant squared theta minus sine theta squared theta. And I told you all that if you know what's on your formula sheet, you will do better. When I see this, I see secant and tan are opposites in the Pythagorean theorem. Well, kind of work together in the Pythagorean theorem. And I see sine and cos work together in the Pythagorean theorem. So I'm literally just going to change secant squared out with the tan one. So then I'll have tans on the left-hand side. And the sine with the cos one. So I have coses on the left-hand side. So secant squared x is just 1 plus tan squared x. Minus sine squared x is 1 minus cos squared x. And then I have to remember to distribute. So I get 1 plus tan squared theta minus 1 plus cos squared theta. The 1's cancel, and it matches. LS equals RS. Okay, then I have the next one. LS, RS. I have cotan x minus 1 over tan x minus 1, and then minus 1 over tan x. Now, if I have something squared, I have the entire formula sheet I can use if it's squared. Even the single ones I can use squared. Like secant squared, I can put 1 over cos squared. Because secant squared is just secant times secant. Correct? But all the singulated, which is what that one is, can only use the singulated formulas. Okay? We're going to Beyonce. So, cotan, well, let's do this one first. Negative 1 over tan could be written as negative cotan x, because that's off my formula sheet. Then the cotan and the tan, I have to change coses and sines. So I could go cos theta, or cos x, over sine x minus 1. And that would be my numerator, divided by sine x over cos x minus 1. Can I flip fractions? Do I currently have a full fraction divided by a full fraction? No. I have to make common denominators so that I can actually get a full fraction. So I can change this 1 to sine x over sine x. And I can change this 1 to cos x over cos x. This is the division that I have right here. And then I get cos x minus sine x all over sine x divided by sine x minus cos x over cos x. Now do I have full fraction and full fraction? Yes, so then can I flip and multiply? Yeah. So I get cos x minus sine x over sine x times cos x over sine x minus cos x. Now, remember, you can look between your sides. You can look between the two sides and see if there's anything familiar. Okay? So I can see that if I cross these two off, I would end up with cos over sine, which is cotan. But I need a negative cotan. Do you see that? You just put it away. It's like you're pretending your key is a sword.
Wow.
That is so cool. All right. So this is a positive cos and a negative sine. And this is a positive sine and a negative cos. So they're the exact same but wrong signs. You see that? They're the exact same but wrong sign. So if you want to change signs, you can just take out a negative 1. So if I take a negative 1 out, This positive cos will become a negative cos, and the negative sign will become a positive sign, and then they'll actually match. Negative cos, positive sign, these two binomials. Then we can cancel them off. Then on the top, we're left with negative 1 times cos x, which is negative 1 cos x, over sine x, which is negative cotan x. Oh my gosh, not the whiteboard. The blackboard is good, yes. Okay. Quiet, please. Yeah? Yes. All right. So, then we have LSRS, and we have 1 minus cos squared x, cosecant x, and then sine x. What is 1 minus cos squared x the same as? Sine squared x. Over 1. And what's cosecant the same as? 1 over sine x. And because they're monomials, I can cross off one of these with one of those, and I'm done. Still one right. All right. Okay. This one, LS, RS. Here we have sine x plus cos x squared. And then we have 1 plus 2 sine x cos x. The problem with the left-hand side is that people will tell me that that is sine squared x plus cos squared x. Remember, when you have a squared, what do you have to do? Write it out twice, correct? So if you go sine squared x plus cos squared x, you're missing your middle term. So always write it out twice. So we get sine x plus cos x times sine x plus cos x. So now we're actually going to get sine x times sine x, which is sine squared x. And then plus sine x times cos x is sine x cos x. Plus sine x times cos x is sine x cos x. Plus cos x times cos x is cos squared x. So if you don't write it out twice, you miss your middle term. So this is a 1 sine x cos x, and this is a 1 sine x cos x, and they're like terms, so if I put them together, what do I get in my middle? 2 sine x cos x. Now if you look at this, this matches that. Do you agree? So we're getting closer. What we have left over is sine squared x plus cos squared x, and it now somehow has to be a 1. Type of your keys. Oh my goodness. Yeah. What is sine squared x plus cos squared x? I could rearrange this if you'd like. Sine squared x plus cos squared x plus 2 sine x cos x. It's 1. So I'm left with 1 plus 2 sine x cos x, which is left side equals right side. So November 8th is going to be your unit exam on chapter 6 and chapter 5, which is a week and a half from here.
We haven't done chapter 5.
Yeah, we're starting tomorrow. 8th, Wednesday.
So basically,
The week after that, what's that? 15th.
oh,
Add 7. We're doing it the test of the 8th plus 7.
Okay. Okay, because you were
AKA the 15th.
You were mad.
Well, if you'd like to have it on the 8th, you can. We won't be done the curriculum, but you can wing it.
I can do that.
All right. 15th. All right. Okay. LSRS. Okay. Then we have 1 minus cos x over sine x. And then we have tan x minus sine x over tan x sine x. So these are all the single ladies again. So we can only switch them out with sines and coses, correct? Yeah, exactly. And the right-hand side has to get swapped out because it looks more complicated. So I'm going to start there. So tan x is sine x over cos x minus sine x over 1, technically. Okay, join me. And then this is my division. And then I have sine x, why is this? Okay, over cos x times sine x over 1. I don't know what that, I can't. Okay, cool. How do I get, what do I do to the numerator? Because I can't do it. I have to make a what? Common denominator. So I'm going to have times this one by cos x and this one by cos x. So I'm left with sine x minus sine x cos x over cos x divided by, what do I get on the bottom? Sine squared x over cos x because it's multiplication. Now do I have a full fraction over a full fraction? Yeah, so I could flip them. What do I see in the top here? Take out a sine x. So if I GCF a sine x out of this top, I'm left with 1 minus cos x over cos x. And then I can flip the bottom. So I'm going to get cos x over sine squared x. I just took a sine x out of here, and then I was left with 1 minus cos x. That stays here. And then this is a division, but I flipped it and multiplied. Then this and this cancel. That and that cancel. And she matches.
Can we go watch?
No. All right. And the last one. Really?
Just getting them off.
I'll get blackboard.
Just brought the blackboard back.
You just hoping you go away, but you're over there. You're going to blink faster. No, it's still there. All right. 2 over 1 minus sine x plus 2 over 1 plus sine x. What are you doing? 4 secant squared x.
You're giving him attention.
Yeah, I'm really just moving my chair back.
I feel like if you were to
Try. All right.
I got this.
I was neglected as a child.
Okay, what do I do on the left-hand side? You have to make a common denominator. So these are not the same thing, and I didn't accidentally put a minus on one of them. Someone asked me the other class. So 1 plus sine x, 1 plus sine x, and then 1 minus sine x, and then 1 minus sine x. So I just distribute the top, and I get 2 plus 2 sine x. Now what is this? Reverse. What's 1 minus sine x and 1 plus sine x? What's that the answer to? I think I heard someone whisper it. The answer to a difference of squares. Right? 1 minus sine x, 1 plus sine x is the answer to a difference of squares. If you don't notice that, you could FOIL. 1 times 1 is 1. Minus sine x plus sine x cancels. Minus sine squared x, correct? If I put them together. If I put these two together, I get 1 plus sine x minus sine x. The middle terms cancel. Minus sine squared x. So this is the same as 1 minus sine squared x. Why would I turn it to that? What is 1 minus sine squared x? The same as cos squared x. So this can be plus 2 minus 2 sine x. So I can write it all over 1 minus sine squared x. And I get 2 plus 2 sine x plus 2 minus 2 sine x. Those cancel. What's 2 plus 2? 4. And then 1 minus sine squared x is cos squared x. And how can I rewrite that? Well, I could either one. If you go like this, 4 over cos squared x. Then I'm going to get you to flip back to your notes to page 8. I want to talk to you guys. We're going to we start chapter 5 tomorrow. On Monday, we're going to spend the first part where we do all the review. You guys go on the boards and stuff like that. We're going to work on just non-permissible values and restrictions because I know people need extra work with that. So we're going to spend the first part of Monday on that before we go back into the second lesson in chapter 5. So that's what we're going to focus on Monday. But tomorrow we'll look at chapter 5. We'll start there. So here it says, consider the expression 1 minus cos 2x and sine 2x. And they want the permissible values, or what you could say is what isn't permitted, and then you'll know what is permissible, right? By just saying, well, we can't do these, so then the rest are permissible. We don't know how to do permissible values of anything with a double angle. So here we have sine 2x in our denominator, correct? So when we're given that, 1 minus cos 2x over sine 2x, the first thing we have to do is switch sine 2x to something else so that we can actually state non-permissible values. So I'm going to go 1 minus, and I don't know what I'm going to put in for cos 2x right now because I don't really care because that's not going to be a restriction because it's not a denominator. But in my denominator, I have sine 2x, and what can I write for that? What can I put instead of sine 2x? 2 sine x cos x. Someone whispered that. Is this a binomial or a monomial? Binomial on the bottom or a monomial? It's a monomial because there are no plus or minus signs. So each of these could go in their own brackets. Because technically 2 is just multiplied by sine, it's just multiplied by cos. We agree? And when brackets butt up to each other, that just means multiplication, doesn't it? So 2 is multiplied by sine, is multiplied by cos. So we just have to say all the places where these could equal 0 and say that x can't be those. So is 2 an issue? No. But we can say sine x can't equal 0, because 2 can never be 0, it's a 2. So sine x can't equal 0, and cos x can't equal 0. Now, why can't they equal 0? Well, if sine x equals 0, this would get replaced with a 0 here in the middle, and I get 2 times 0 times cos, which is 0. Then my denominator would be 0, and I have a problem, right? If cos x equals 0, then this bracket would be 0, and then I have 2 times sine x times 0, which would make my denominator 0, and I can't have my denominator be 0. So I have to state all the x values where sine x would be 0 and where cos x would be 0 and say x can't be those. Because if it was, my denominator would be 0. So where is sine x equal to 0? Well, where y is equal to 0, which is here and here. So that's sine x can't equal 0. And where does cos x equal 0? At 90 and 270. So if I actually get both of them, could I put their non-permissible values together and just say every 90? It can't happen, technically. So I start off with my smallest positive, and I say x can't equal 0 degrees. That's my smallest, it's right here. And the next one happens at 90, then 90, then 90, then 90. Or I could go the other way, 90, negative 90, negative 90, negative 90, right? So it's every 90. So I go 0 plus what? 90 degrees, n, and then n EI. N is an element of the integers. 1, negative 1, 2, negative 2, 0, all those. Do I have to write the 0 degrees? No. If I do 0 plus something, does it affect it? No. So am I wrong if I write the 0? No. But they won't write the 0 as a multiple choice option. So how they'll write it is 90 degrees n, NEI. Now I know that this cos 2x needs to get replaced. The problem with cos 2x is there are 3 formulas. And here it says simplify the expression to one of the 3 primary trig ratios, or trig functions. So that's sine theta, cos theta, or tan theta. Those are my options. So I have a 1 here. If I have 1 plus something, it's a binomial, and I'm never crossing anything off, correct? So I want the 1 to go away. Putting in the first cos formula, on here, the first cos 2x formula, cos squared x minus sine squared x, is that going to be helpful to get that 1 to go away? No? If I fill in the 2 cos squared x minus 1, will that help? It'll end up being negative 2 cos squared x plus 1. So I'm going to get a 1 plus 1, which is actually 2. Did it go away? No. If I put in the 1 minus 2 sine squared x, let's see. Because I'm replacing it, I have to put it in brackets, and I have a minus sign in front of it, right? So I get 1 minus 2 sine squared x. I have to remember to distribute. So whenever you substitute in a formula, if it doesn't have a plus 1 in front of it, you have to remember to distribute through, right? So this was a negative cos 2x, and I'm replacing cos 2x with this. So I have to remember to distribute my 1 through, that negative sign through. So I'm going to get 1 minus 1 plus 2 sine squared x over 2 sine x cos x. Those cancel off. 2 sine squared x is the same as 2, and I could technically go sine x over 2 sine x cos x. Monomials, what's sine x over cos x? Tan x. Okay, then we're going to flip ahead to example 5. We did this yesterday, going here. I star example 5 and 6, not because they're hard, but because everyone forgets they exist in this unit. We prove so much, everyone knows you're going to have some proofs. We verify, everyone knows we're going to have verifications. Non-permissible values we know. But people forget about these. So, these use chapter 4, but here it says, given cos A equals 3 over 5 and cos B equals 5 over 13, and A can be found between 0 and pi over 2, and B can be found between 3 pi over 2 and 2 pi, find the exact value of cos A plus B. I immediately draw to this. So I'm going to do this over here. Cos A plus B. Cos A plus B is not cos A plus cos B. We talked about this yesterday. What do I have to do when I see cos A plus B? What do I immediately have to do? Formula sheet. Go to my formula sheet. Do not distribute. Distribution does not work, right? Go to my formula sheet. My formula sheet says cos A plus B is cos A, cos B, minus sine A, sine B. And personal preference, I wish they did this, they don't. I put brackets around these because they are multiplied, and they're going to be completely replaced. So I technically get cos A plus B equals this, and they want to know what cos A plus B equals. So can I fill anything in here? Did they give me something? They gave me cos A and they gave me cos B, did they not? Cos A is 3/5. So I go to cos A, I rip it off the board, I hack the entire thing away, and I replace it with 3/5. Not cos 3/5, 3/5, because cos A is 3/5. Cos A, rip off, 3/5, put in. Cos B, rip off, throw it away, replace with 5 over 13. And then often this is what I get to see on a test. People stop here and are like, me? You need to make triangles like you did in chapter 4 with your trig ratios. This is x over r. Cook extra rice. This is x over r of a B triangle. I need to find y. I need to draw a triangle to know if y is positive or negative. So I'm going to use Pythagorean theorem, and I'm going to get a plus or minus. Yeah. Yeah. So, if I do the first one, I know A, cos A is found between 0 and pi over 2. So it's here. That's not straight. So, x is 3, r is 5, y is positive something because I drew it here, and this is triangle A. So I'm going to get y squared equals 5 squared minus 3 squared. Y squared equals 25 minus 9. Y squared equals 16. Square root, plus or minus. Y equals positive 4. I need sine of A. Can anyone tell me what sine A is? Sign your resume. So what is it? 4/5. So then I can go over here to where sine A is, rip it off my board, throw it away, and replace it with 4/5. Do you see that? Then I still have to do the B triangle, right? Because cos B is 5 over 13, so it has different ones. And this one says B is between 3 pi over 2 and 2 pi, so quadrant 4. No, but if I close my door, it's actually quite quiet. So x equals 5, r equals 13, and then y equals negative. See, that's why I have to draw it. And then this is triangle B. So I get y squared equals 13 squared minus 5 squared. Y squared equals 169 minus 25. Y squared equals 144. square root, plus or minus in front. And I know y equals negative 12. And now I need sine of b. Because that's the last thing I need to replace. What's sine of b? So, negative 12 over 13. Sign your resume. So I'm going to get 15 over 65 minus negative 48 over 65. What happens when I get a minus? You add them. 15 over 65 plus 48 over 65 equals 63 over 65. Okay, you guys try the next one out. The next one doesn't give you two triangles, it only gives you one, but it gives you 150 degrees. Oh, that was not intentional, Jesse. Sorry.
I didn't know I was that bad of a student.
It was not intentional. I didn't know you were there. So draw out your formula first. All right. So we get cos x, cos 150 degrees, minus sine x, sine 150 degrees. We can get 3 of these without doing any work. Cos of x is not given to us, so there we go. That's the one we have to say. I need to write it. So cos of x is the one that's going to sit here. All right, please. What's cos 150? Negative root 3 over 2. Minus sine of x is negative 1/4. Sine of 150 is a half. Then we have to get cos x. So it says here that sine is between 90 and 270. Its sign has to be negative, so it has to be in quadrant 3. So y equals negative 4, r equals 5. If you don't draw it in the right one, you're going to figure out that y is negative 4 can't exist in quadrant 2, right? And then x has to equal negative something. So I go 5 squared, x squared equals 5 squared minus negative 4 squared. X squared equals 25 minus 16. X squared equals 9. Square root plus or minus x equals negative 3. And I need cos of x. X being the triangle. Like this is triangle x. I know it bothers you when you put an x there. If it's theta or a or b, you guys feel a little better because you think it's just x. It's not x. They're just calling it triangle x instead of triangle a and b we looked up. So cos is cooked extra rice. So we get negative 3 over 5. And we replace cos x with negative 3 over 5. Then we multiply numerator times numerator. So this is grade 11. So you always, when you multiply radicals, you multiply coefficient times coefficient, radicand by radicand. What the heck does that mean? Number in front by number in front, number under radical by number under radical. So in this case, there's just a number in front and a radical. So I just multiply them like normal. They can't go together other than just being wrote beside each other. So written beside each other. So negative 3 times negative root 3 is just positive 3 root 3. All over 10. Minus a minus, so plus 4 over root 10. And then I just get that, all over 10. You can I put these together? That's like having 3x plus 4. Can I put those together? No. So you can only add radicals that have the same radicand. We taught that in grade 11 as well. So as soon as it gets 3 root 3 plus 4, all over 10. Your homework, the stuff that's like this, is page 307. number 19, 20AB. And then I want you to practice some out of that written book, the same handwritten one we've been doing. NOPQ 3EF. You have like 20 minutes. Literally. Work. 20 minutes.